says Math 110, lab number 17. Talk about a logarithmic function and how it relates to transformations, domain, range, um, asymptotes, the intercepts, and increasing and decreasing. So here's our logarithmic function that we're going to look at here. F of x is equal to log base 2 of x plus 8 and minus 5. So we want to discuss what's going on with that graph. So let's first graph that function. So I'm a graphing calculator, go to y equals, clear out anything else you have, and we want to use the log base function of our calculator. So we hit math, press the up arrow, and we're looking for log base, and I choose log base, and then the base of a 2, and then I'm typing in x plus 8 inside of the log, press the right arrow key, and minus 5 outside of the parentheses, hit graph, and we see our graph of that particular function. So then let's go answer some questions about that. So let's talk about the transformations of that graph on f of x equals log base 2 of x. With the minus 5 on the outside, we see that would be a vertical shift down 5 units. So that would be down 5 units. And then the plus 8 on the inside is going to shift this to the left 8 units. Left 8 units. Using the same rules for transformations that we've used the entire class 100 and 110. So let's then look at the domain of the function f of x equals log base 2 of x plus 8 minus 5. So the domain of a basic log function is from 0 to infinity, and by shifting this to the left 8 units, that's going to start it at negative 8 to infinity. But you can also find the domain by taking whatever's inside of the logarithm. In this case, it's x plus 8, and setting it greater than 0. So because we cannot take the log of 0 or a negative number. If we solve that, subtracting 8, x has got to be greater than negative 8. So the domain is all x's as long as x is greater than negative 8. That's the set notation. Negative 8 to positive infinity is the interval notation. Along with the domain, you get a vertical asymptote. If we look at our graph here, we can see here at negative 8, the graph becomes more vertical, and there is a vertical asymptote there at x equals negative 8. So this particular graph corresponds directly to the negative 8 that is in the domain. The range would be from negative infinity to positive infinity. Look at our graph. It goes down toward negative infinity here, and it continues up, albeit slowly, to the right to get to positive infinity. In order to find the y-intercept, we plug a 0 in for x. Base 2 of 0 plus 8 minus 5, and base 2 of 8 minus 5, 3 minus 5, which is negative 2. The y-intercept is at 0, negative 2. We can also see that in our graph right there at negative 2. If I hit trace negative 2, trace 0, and there we have the y-intercept of negative 2. The x-intercept a little more difficult to find. Log base 2 of x plus 8 minus 5. We set the problem equal to 0, and then move the 5 over. Log base 2 of x plus 8 is equal to 5. And then we exponentiate with a 2 inside. So we have x plus 8 equals 2 to the 5th power, which is 32. Subtract 8 equals 24. So 24 0 is the x-intercept. So setting the problem equal to 0 will always find an x-intercept if there is one. If we look at this graph and read it left to right, we can see easily that this function is increasing across the entire domain. And there is Math 110, lab number 17.